Hello, here's video homework number 3. So we're going to identify the type of transformations. For number 1, we have a horizontal shift left 4 and a vertical shift down 1. For number 2, we have a horizontal compression by 5. Number 3, we have a horizontal compression of 1/5. And number 4, we have a vertical reflection, because of this negative, and then a horizontal compression by 3. We know this because when it's inside the parentheses, it is a horizontal shift because this is the input and then this is the output, which is the vertical. So it's going to change the graph. It'll move for this one, like for number 1, your line is going to move down 1 and then left 4. So it's going to look different. For problem 2, we first had to identify the base function. So for number 1, the base function is x squared. Number 2, which looks like this. Number 2 is square root x, which looks like this. Number 3 is absolute value of x for the base derivative, and then, wait, no, that's not right. Like that. And then that's what all that is about. Yep. So that's the base derivative for each problem. First, next describe the transformation. So for number 1, you're going to do a horizontal shift left 1 and a vertical shift down 3. So it ends up the vertex being -1, -3, which we could easily grab from the problem. Number 2, it's a vertical shift up 3 and then a horizontal shift left 2. That gives us a vertex of -2, 3. Here's what both of those graphs look like. For number 3, it's a horizontal shift right 1 and a vertical shift up 4. The vertex is 1, 4, and then here's what the graph looks like. Since its absolute value was our base derivative, our graph is going to look like a V. For number 4, we have a horizontal shift right 2 and a vertical shift down 1. Our vertex is 2, 1. And here's what our graph ends up looking like. Yeah. Explain how each constant affects the graph's position. Each constant affects the graph's position or shape. First of all, we don't have a compression or a stretch, so our the line of what's drawn on the graph isn't going to change. Just the position is going to change. Just like for number 1, we have a horizontal shift left 1, so we start here. You have to go left 1, and then but we also have a vertical shift down 3. So 1, 2, 3. So here's where we start. That's our vertex, and so that's how the position moved from the origin. Same thing for number 2, 3, and 4. I already explained the transformations, and we can see it moved up 3 and left 2, like we said right here, from the origin. So now we have the point graphed like that. Same thing for this. We start at the origin. It went right 1 and up 4. So now that's where our new vertex is. And same thing for this. Started at the origin, went right 2, down 1. Now for number 3, we have to check if they are inverse functions. So here's where I wrote that over here. I just did the thing we learned in class, where you start with the problem, and to check if it's inverse, you have to switch y and x and y. So I did that here. Then to get, is this number 1? Yeah. To get rid of the cube root, I cubed it, which got rid of that, which got rid of the root. So we were left with x3 equals y minus 1. Move the 1 over, which gives us y equals x3 plus 1, which is g of x. So they are inverses of each other. Yes. For the domain of f of x, it's negative infinity to infinity. Same thing for the range. It's all real numbers. And here's what it looks like on the graph. As you can see, negative infinity to infinity. Same exact thing for g of x. This is g of x, negative infinity going up to positive infinity. Yeah, so there's the sketch of them. The two graphs are reflections of each other. Yes. For here, when we're checking if they're inverses of each other, we plugged in finding f of g of x and also finding g of f of x. And we both ended up with an x. So yeah, literally stated it on the last page. So number 2, we're given f of x is negative 3 plus 5, and g of x is x minus 5 over negative 3. So we did the same thing here, just switched the x and the y. And we end up with y equals x minus 5, which is exactly what g of x is. So we know they are inverses. We also can plug them in and make sure when we're doing f of g of x and g of f of, ooh, golly, it's a mouthful. And we both ended up with x. So yeah, that's good. The domain of f of x is negative infinity to positive infinity. Same thing for the range, negative infinity to positive infinity. Also the same exact thing for g of x. As you can see, this is our line for f of x. What was I gonna say? Yeah. They are reflections of each other. For number 3, we did the same thing to find if they are inverses, switching the y and the x. And they end up not being inverses. No. Why? Because when you are finding a square root, you have to have positive and negative. And obviously we know we can't do that. So it does not work. Here's the graph. This is F, this is G. They're not inverses because x squared plus 1 fails the horizontal line test. If we do that, like that, there's 2 points. X squared plus 1 fails the horizontal line test, and when you're solving x equals y minus 1, you end up with x positive and negative y minus 1, which you can't do. If you flipped it over the line y equals x, wouldn't it be good? The two x values for one y, so it wouldn't match or mirror each other. Yeah, so that does not work. They are not inverses of each other. Now for number 4. This is our problem, x squared plus 6x plus 4. The vertex is 3 equals -5. The domain is negative infinity to positive infinity. Range is -5 to positive infinity. Vertex form is x plus 3 squared minus 5, which is also shows up on the graph because just like we were learning from before, this is a vertical shift down 5, and here we're down 5, and a horizontal shift left. And then for the y-intercept, we have 0, 4, and the x-intercepts are -3 plus and minus square root of 5. And our axis of symmetry is x equals -3. I just realized, I think this is supposed to be, I just realized, I messed up. I think this is supposed to be -3, and this is supposed to be -3. So pretend that this is over here, okay? Okay. For number 2, we have 2x squared minus 4x plus 4. Vertex is at 1, 0. Domain is negative infinity to positive infinity. Range is 0 to positive infinity. Vertex form is 2x minus 1 squared. We know this is a vertical shift of right 1, and it's also a parabola. The y-intercept we can easily find from right here, which is 2, 0, 2. The x-intercept is 1, x equals 1, right there. Our axis of symmetry is at 1. And here's those clearly labeled. And yeah, that's about it. Bye.